Hi, algebra. We're going to keep working on simplifying radicals. We're going to look at how to simplify when you have a fraction, and we're going to look at how to simplify when you have variables, because of course we have to do it with letters. It wouldn't be algebra if we didn't. So at the beginning of this lesson, and if you look back at the start of this, we had this product rule here at the bottom that said that you could split a radical into two things being multiplied to each other. So you could split a radicand, that's the number inside, into its factors, or you could go the other way. You can do the same thing with fractions. So if you have, here's what we're seeing here, is we're seeing an individual radical and an individual radical. So it went from 2 to just 1. See how we did that? What that allows us to do is then reduce and divide B into A, or just reduce if it's possible. So for, we'll do an example in a second. The other way is to go backwards, is if you have one big radical, you can make it two little radicals. Perhaps, when would you want to do this? You would want to do this when they're a perfect square, when you can take the square root of that number. So let's do some examples and we'll use that. What we have here in the square root of 25 over 49 is one big radical. Now, do I recognize these numbers, 25 and 49? If you have your note card or your Post-it or your list of all the perfect squares, you'll see that 25 and 49 are on there. So what we can do is we can write these as individual square roots, and we can simplify them. What is the square root of 25? Now, remember, you do not put a radical in your answer if it's a perfect square. It equals 5, because remember, this is asking the question. When you see this symbol, it asks the question, what number do you square to get 25? So your answer is just whatever goes in the question mark spot. It would be 5, right? Because 5 squared is 25. I don't have a square root left. It is just simply 5 over 7, and that is your final answer. There are no square roots because these are perfect squares, so you don't need them. There's only radicals left in your answer if it was an irrational number. If it's not a perfect square, then you have a number left in the radical. This next example, the square root of 20 over the square root of 5. The square root of 20 isn't a perfect square, and the square root of 5 isn't a perfect square. So I can't just take the square root of them. But I could make it a giant fraction under the radical and divide that, because 5 goes into 20. 5 goes into 20 4 times. So that becomes 4 over 1, which is just, the square root of 1 is 1. But then this becomes 2, because you're answering the question, what number do you square to get 4? And the answer is 2 squared equals 4. So that's why the answer is 2, not the square root of 2, but 2. All right, let's go across. The square root of 6 over 25. So that's one big radical. I can't reduce that. Nothing goes into both of them. So I could make this the square root of 6 over the square root of 25, because 25 is a perfect square. So this becomes the square root of 6 over 5. And you can leave it like that. Later, we might have time to learn this, but it's called rationalizing. And you'll see it where we don't leave a square root in the denominator, but we'll get to that later. All right, so this next example is the square root of 5 over 64. Again, I can't reduce that because nothing goes into 5 and 64, but I recognize 64. So I'm going to make this the square root of 5 over the square root of 64. So that is the square root of 5 over what squared gives us 64? 8. And you can, again, just leave it like that. What if you had something like this, the square root of 3 over 6. Could you reduce? Could we reduce this? The answer is no. Why? It is not 3 over 6. That could be reduced to 1/2. It's not 3. It's the square root of 3 over 6. The square root of 3 is 1 point. I don't know. I don't remember that. Square root of 3 is 1.73205, and it goes on forever. That's why it's irrational. Over 6. It goes on forever and doesn't repeat. That's why it's irrational. So this is the same thing as this. Does this reduce to 1/2? Does that equal 1/2? Not at all. No, not even close. So I think it helps, 3 over 6, but the square root of 3, you've got to remember, is a totally different number. It's 1.7, blah, blah, blah. And 1.7 over 6 is not 0.5 or 1/2. It's nowhere close to that. So just keep that in mind. Go slow and work through this. All right, 48, square root of 48 over the square root of 3. Well, neither one of those are perfect squares, but 3 does go into 48. How many times does 48 go into 3? 16 times. So this becomes, so I divide by 3, 1, and 16. So it becomes the square root of 16. What is the square root of 16? 4. So there are our answers to all of those. So if this seems a little confusing, go back, walk yourself through, pause the video, ask yourself the questions that I'm pointing out, like can we reduce it? Or are any of these perfect squares? That's what you've got to look for. Now, of course, we can combine those two options. We can multiply and divide. And so this gets into a smidge of multiplying. Let's see, I could do the square root of 1 times 5 over the square root of 2 times 18. So I can make it so that the numerators are being multiplied and the denominators are being multiplied, just like I would any other time I had numbers in fractions. So I can make this the square root of 5 over the square root of 36. Oh, I know that. The square root of 5 is 5, and the square root of 36 is 6. And that is our final answer. Let's see. 512 divided by 27. Nope, doesn't work. Let's see. So what about 512 divided by 9? Nope. Okay. So never mind. So let's do 8 times 512. Yikes. What is the square root of that number? Haha. This is the square root. So we do 8 times 512. And that is the square root of 4096 over 3 times 27 is 81. The square root of 3 times 27 is the square root of 81. Now, so you see what I've done? I've just multiplied these two together, and then I've multiplied these two numbers together. The square root of 4096 is 64. The square root of 81 is 9. Now, does that reduce? 64 divided by 9 is not even. Let's see, does... No, that's it. That's your final answer. Oh, yeah, because 8 and... Yeah. Okay, that's it. Now, let's get into variables. So the thing to know here is that any variable is a perfect square. Any letter, X, Y, Z, A, B, C, M, N, P, whatever. They're all perfect squares if their exponents are even. As long as the exponent's even, it's a perfect square. So x to the second, x to the fourth, or y to the fourth, z to the 10th, a to the 12th, b to the 100th, c to the 8th, m to the 18th, n to the 24th, p to the 56th. Anytime it's even, those are perfect squares. So let me show you how to find the square root of them. Remember that the square root symbol is asking you, what do you square? Well, with exponents, if it's being multiplied, you add the exponents together. So in this case, the square root of a to the 4th, we're saying, what do we square to get a to the 4th? Well, remember when you had whatever you have in there, you multiply the exponents. So what times what is 4? 2. So this would have to be a to the 2nd, right? So that would give you a to the 4th. So a to the 2nd is what you square to get it. So that's why a to the 2nd is the answer. What do you square? What do you square to get a to the 6th? What goes in here? What is this stuff right in here? A to the 3rd, because you would do 3 times 2 gives you 6. What times what gives you a to the 8th? What do I square to get? What do you square to get a to the 8th? You have to have a to the 4th, right? 4 times 2 is 8. So what you'll see is 2, 4, 3, 6, 4, 8. You are halving these. You're cutting them in half. So just take that number, slice it in half, and there you go. So the square root of a to the 10th is a to the half of 10, 5. Why? Because a to the 5th times a to the 5th is a to the 5 plus 5, a to the 10th. Or a to the 5th squared is a to the 10th, because you do 2 times 5. What is the square root of a to the 20th? Oh, sorry, no square root, because it's a perfect square. Why is it a perfect square? Because it's even. That would be a to the 10th, half of 20. A to the 100th. Now be very careful, because 100 is a perfect square, but it's not the base. A is the base. The exponent is 100. So remember, it's saying, what do you square to get a to the 100? It has to be half of that, so 50. A to the 50, right? Because 50 times 2 is 100, or 50 times a to the 50 is a to the 50 plus 50, which is 100. So you're cutting them in half. So how do you know if a radical with an exponent is perfect? You know it's perfect if, and only if, its exponent is even. And you know, to solve that, you just have to divide the exponent into half. So let's look at this next example, or divide it by half. The square root of 4 x squared. Sorry, I'm taking my lunch out of the oven. So 4 is a perfect square. The square root of 4 is 2, and x squared is also a perfect square. So sometimes it's helpful to split this up if you want, and say, okay, the square root of 4 times the square root of x squared, and just deal with them individually. The square root of 4 is 2. So I'm going to change that to 2. And the square root of x squared, is this perfect? Yes, because it's an even exponent, is x. So the answer is 2x. And this makes sense. What do you square? So this is asking the question, what do we square to get 4x squared? So what goes in there to get 4x squared? Well, it has to be 2, because 2 times 2 is 4. And what do you square to get x squared? X, 2x. Boom. Okay, next one. The square root of 18x squared. Well, again, we can do this, 18 and times x squared, because they're being multiplied inside the radical. I know this one right here, that's x, right? Perfect square. Now, let's deal with this. Remember, we ask ourselves, what perfect square goes into that number? 9. 9 goes into that. So that's the square root of 9 times 2, which we could split into the square root of 9 times the square root of 2 times x. All of this is being multiplied together. All of this is multiplication. So that's 3 times x times the square root of 2. So you'll see that written just 3x root 2. That is how you write it. Why is the 2 still in the radical? Because it's not a perfect square. The 18 is not a perfect square, and that 2 doesn't get to come out because there's not 2 of them. It's not a perfect square. There's only one of them. Okay, same thing here. Let's see. This 98's not on my list, but we can reduce it. So, oh, this is awesome. That's a perfect square. It's even. So what's half of 6? Half of 6 equals 3. So this will be x to the third. And let's see, 98. What perfect square goes into 98? Let's try, 16 doesn't work. 98 divided by 9. Nope. 98 divided by 36. Nope. 98 divided by 4, maybe? Maybe I'm trying too big of numbers. No, 4 doesn't work. 98 divided by 4, 9, 16, how can be 25? 36, did I try that? Yeah, 36, 49? Oh, 49! I should have known that. Okay, so that's 49 times 2. So the square root of 49 times the square root of 2 times x cubed. So the square root of 49 is 7. I'm going to put the x cubed in front and then the root 2 because we like to keep everything that's outside of the radical together in the front of the radical, so it just doesn't get confusing what's inside and what's out. Okay, now, cool. What happens then if the square root of the variable doesn't have an even exponent? Well, it's the same as if you have the square root of a number that's not a perfect square. You have something left in the radical. So if it's not even, I could split this up into b times b times b. There's 3 of them, right? Anytime you have a pair, that means there's a perfect square. So this is really just b squared times b, right? So that's to the first, and 2 plus 1 is 3. This is a perfect square. B squared times the square root of b. The square root of b squared is b times the square root of b. And that is your final answer. So I think the easiest way to do that is to say, okay, if it's odd, right? Just subtract 1. Because if you subtract 1 from an odd number, you're going to get an even number. Just always happens that way because the pattern is even, odd, even, odd, even, odd, even, odd. So subtract 1. And when you do, you get to this case right here. So let's do this next one. B to the 7. Imagine you have 7 kids in a classroom and you have to partner up. Okay. Is someone going to be left out? Yes, because 7 is odd, right? How many pairs are there going to be? How many pairs are there going to be? There's going to be 3 pairs and then 1 person who's left out. Subtract 1 from, so remember that. Hold on for a second. Subtract 1 from 7 and you get 6. So b to the 6th times b. What is b to the 6th? What is the square root of b to the 6th? Oops, now I'm getting messed up. B to the 3rd. Remember how I said I asked you how many pairs there would be? 3 times the square root of b. Next one has a coefficient of 16. The square root of 16 times the square root of f to the 9th. The square root of 16 is 4. I know that right off the bat. Now, 9 is odd, so I can subtract 1. And so then you get the square root of f to the 8th times f to the 1st. So how did I get 8? I just took 1 away. Just took 1 out. Now f to the 8 is even. And so it's a perfect square. It's 4f to the, what's half of 8? 4 times the square root of f that got left over. So guys, anytime you have an odd exponent, you know you're guaranteed that you're going to have a letter left in your radical. And you could see problems like this. These are awesome problems. X to the 10th, y to the 12th. Guess what that's going to be? Even. So x to the 5, y to the 6th. Boom, done. Remember, what do you square to get x to the 10th, y to the 12th? You square x to the 5th, and you square y to the 6th. Now, let's try this. X to the 11th, y to the 5th. Am I going to have any x's left in the radical? Yes, because the x exponent's odd. Am I going to have any y's left in the radical? Yes, because the y exponent's odd. So I subtract one from each so I can find the even one. So x to the 10 times x and y to the 4th times y. Perfect square, perfect square. Take half of it, so x to the 5th, y to the 2nd, and I'm left with x, y, these two right here in the square root. And that's your final answer. All right, I'll see you later.